So lately, oh, by lately I mean the last like 3 days, I've been unbelievably unproductive. So really just trying to get my life together, cleaning my apartment, going to try to cook, meal prep a little bit. So I'm not ordering Uber Eats. Although that Taco Bell the other day was fine. It was very good. The Caliente Cantina menu. They did something. They did something with that. I hope that someone found that last video useful. I think I do want to do like more kind of just like talk to the camera type videos. Kind of like, I don't want to call them advice videos, but I guess that's what they are. But yeah, today I am, to be honest, feeling a little down. I don't even know why. Because like things are good. I went on like a 6-mile walk yesterday. I could just be fatigued and tired, but I almost didn't turn on the camera today. But this video is a reminder to turn on whatever your camera is. That was corny. But yeah, just do whatever it is you're putting off. That's what I'm trying to do. And please wish me luck. Because this shit's hard. Life got hands, bro. All right. Thank you for watching as always. What should I do this video? I don't know. It might just be another yap sesh. Actually, let's talk about this channel a little bit. So I was thinking about where I kind of want to take the content. I know my most popular videos are just like me sitting at a computer yapping and typing away at the compiler, but I do want to branch out a little bit. Maybe just like some regular vlogs, not necessarily where I'm programming, but I feel like that will definitely tank my analytics, but who knows. If it doesn't matter. I don't really care that much about how many views I get. I would like to make this. I don't know. Do I want to make this my job one day? I go back and forth on that. But obviously, if it's my job, I'd have to get views. I'd have to actually probably niche. But I'm not a big fan of niching. I have a lot of interests outside of programming. I don't know. That's just yapping. That is my main interest. That'll never change. Your boy's gonna yap forever and ever. Few things I'm working on though. Haven't really picked up the compiler. I thought about making a little tutorial-esque video on Metal, which is Apple's graphics API. I was thinking about doing like kind of a series where I render a triangle in each graphics API, OpenGL, Metal, DirectX, and Vulkan, and kind of compare and contrast. That could be fun. So maybe I'll start doing that this week. Outside of that, I don't know. I'm just like I'm talking to the camera like it's my therapist. I need to bring some energy to this shit. Whatever. Let's clean my apartment and maybe hit the gym. That's what I really need to do. I'm gonna hit the gym. It's super late. I don't normally go this late. But I kind of need to like just move around. I've been laying in bed all day because that walk hurt my legs. So, all right, let's. I just got a notification that it's time for me to go to sleep. No, I'm not going to sleep. All right. Anyway, Let's see if I can force myself to the gym. I wear every single chain even when I'm in the house. And you take all this shit off because I don't want the audio jingling and jangling and stuff. It's just the trials and tribs of being a fashion girly. I always have to look good. I always have to be dripped out. If you're not, honestly, like motherfuckers stop fucking with you. It's unfortunate. I don't like this life. I don't like that I have to always be the best dressed in a room. It's like, come on, I'm just a normal person. Just let me be normal. Okay, I'm stupid. All right. Anyway, let's. I kind of want to. I know I was just like, I don't know when I'm gonna do this video, but I was actually thinking, might as well do the metal thing while I drank my pre-workout. I feel like it's almost become a tradition to drink the pre-workout and code at the same time. This is actually non-stim pre-workout because I've been really drinking too much caffeine. So I am actually gonna try to not make my heart explode just yet. I want to live to at least 40, like 5 more years, like at least. All right. All right, I'm gonna shake this up and then I'm going to start recording my screen. So let's show you how to render a triangle using the Metal API. Actually, I'm going to delete some of this because what's the fun in just explaining it and not actually coding it. Okay, so to render a triangle in Metal on using SwiftUI, we actually have to use a view controller. Even though it's SwiftUI, I used to have to use a view controller because there's no SwiftUI view for Metal. So I created a struct called Metal View, and that's going to be over here. And that will implement NSView representable. I'm building this for Mac. If you want it to be on iOS, you would do UI view representable. And after that, we have a class called Renderer that just implements this MTK View delegate. So MTK View is a view that inherits from either NSView on Mac or UI View on iOS. I don't actually need to be wearing it. On iOS, it's UI View, and MTK View is just provided to show the actual Metal viewport. So for this Metal view, we just need a variable to hold the renderer that we created over there. And we want it to be a state variable so it updates automatically. So we're gonna say renderer renderer. Okay. And then on my secret second screen, I'm going to have the actual code that I'm going to be using that I already wrote. All right. So need to implement two methods for NSView representable, make NSView and update NSView. For our purposes, we don't actually need anything in update NSView, but if you wanted to update something, when something changes, that's where you would do that. Here we just have to create the actual metal view. So it's going to be MTK view. So for a metal view, you just have to set a bunch of different properties on it. So you want to set your preferred frames per second. You want to set enable set needs display to make sure that it updates when you start the app. So set that to true, and then we have to give it a device. So a device in this context would be a GPU. Since we don't really care too much like what device we get, we just want to get whatever's the default GPU for your device, for your computer or phone. So we just say MTL create system default device and set it to view, to the view. Then we want to set frame buffer only to false. I forget exactly what this is for. Draw texture. Okay, so this is something I don't remember. I think if you set this to true, it will be slightly more performant, but it'll be less flexible. I don't remember exactly what it does though, to be honest. But we're just gonna set it to false. If you care, goddamn, look it up, bro. I'm a terrible teacher. So, and then lastly, we have to say, is it paused? We set that to false to say update it every 60 frames per second. If you don't do that, I found in the past that it won't honor this part. It'll just like render one frame and stay there. And then we also need to set the delegate to our renderer. And then we just need to return the view and boom. All right, so we have that. And then we have to set up our renderer. So in the renderer, we have to like set a few properties. So I haven't actually been drinking my pre-workout. I just realized. Wasting time. All right, so need a few things. Why did it just change? Do not disturb to personal stuff. All right. So we want to hold a reference to the device. That'll be MTL device. And we need to hold a reference to something called pipeline state. So that is basically tells the renderer all the things it needs to know to actually render something. You like set your shaders and stuff in here. So, pipeline state, and Okay, we also need a command Q. Okay, we will add that in a second. Command Q. Let's call it TL. Command Q. So this, what is command Q? Wait, sorry. Okay, command Q allows us to grab a buffer. Yeah, it allows us to grab a buffer that holds all the commands that we want to run on the GPU. Okay. And I believe that's all we need to hold onto. So we're just gonna not do that actually. We're gonna say init. So we're actually gonna do the same thing. Actually, yeah, we're gonna make these optional, just because they all return optionals. You can throw like an error if they end up being nil, but I'm not super worried about them being nil. Okay, so first of all, we want to set the device. So we got set our device. We have to also override, and at the end we want to call super again, because this is inheriting from NS. Okay, so what we need first is a library, and the library just holds your shaders. So try device. We're gonna make a default library. So once we have that, we want to grab our shader functions. So we're gonna say vertex func will equal library, and so we don't actually have the shaders just yet, so we're gonna have to create those in a second. So, but for now, we're just gonna say make function, and then we're gonna call it shader. And then next we have to set up the pipeline state. So a lot of the stuff you create, you do it using what's called a descriptor. So pipeline state has a descriptor type, and it's what it sounds like. Use it to describe the pipeline state. So we're gonna say render pipeline descriptor. We're gonna say pipeline descriptor. We have to give it a label, so I just call it render pipeline. You can have multiple ones, so that's why you have to label them. So we set our vertex function to vertex func. Set fragment func to fragment function, and then we have to set the color information. So default for this is usually BGR8 uniform, and then okay, we don't need that. And then from there, we will just set our pipeline state equal to device dot make pipeline render state from pipeline descriptor. And then lastly, we just have to set the command queue. That should be device make command queue. Errors thrown handle. Oh, it's gonna. Oh yeah, both of these I'm just gonna say. Oh, I didn't even try there. Okay, so for this try, I'm just gonna put a question mark. So it'll just return nil if it doesn't work. Since this is just we're just lollygagging, it's not a big deal. Okay, so only other thing, we actually do want to hold on to the viewport size. Gonna import SIMD, which has like different vector types we can use, and then all right, so SIMD2. What was that? Oh, okay. So I was we just have some UN32s, so the viewport size, and then wait, why did it do it as viewport size? I think this was I forgot the equal sign. Okay, so we have our CG floats. Actually, we could just do float. All right, cool. All right, so we have a vector of floats here, and then whenever the drawable size will change, we want to set viewport size to the new size. So X is equal to width, Y is equal to that beeping is my rice cooker. And we have to cast them. Okay. All right, so all right, now the fun begins. We're actually going to draw. So in this method will be called every frame, and this is where we actually do the actual drawing of things. So this is where we will create a triangle. So if you're not familiar with graphics programming, basically we will pass some vertices to the GPU. The GPU will use those to draw whatever we want, and we tell it basically what triangles to draw. This in this situation is just going to be one. So let's see. All right, so we have to create a descriptor for the render pass. So we're going to say pass descriptor. and that, or we actually don't have to create it. We have to just grab it from the view, and then we grab a command buffer. From the command queue. And we need to set a label on the command buffer because, again, you can have multiple. So we're going to say command, and then we want to say let render encoder. So render encoder is what you actually used to use the drawing. So we will don't want to compute encoder. I want to make a render command encoder from that descriptor. I may need to. Yeah, it's optional. So say guard. Okay, so if it fails, we just want to throw a fatal error. Okay, and then I think I'm gonna do that here too. Because if this stuff doesn't work, then what are we doing? All right, so we have to set a label on the render encoder. You know the deal. And then we have to set the viewport. So that's what we're doing up there. So, yeah. So what we got up there, we will just use that. So origin is 0, 0. Width will be casting. Viewport x to a double viewport y to a double z near and z far you can just set to 1, 0, 1. Okay, and then we want to set the pipeline state. This will probably. All right. Okay, now we just need to we have to set the vertices. So let's see. I don't want to type all this out, so I'm just gonna copy and paste what I have. So for a triangle, we actually can have some vertices. I need the actual type here. Okay, so all right, so we have a vertex, and all it does is have a position and a color. And then, okay, so I don't need this. I also need, I'm copying and pasting this from my little toy game engine. So, all right. So we have position and we have a color. Position will just be X, Y, Z, and W coordinate. These are homogeneous coordinates. And then the color is just RGBA. So it'll be go from red to green to blue. And let's go back to the renderer. All right, so I want to just set the bytes for this on the render encoder. So we're just gonna say set vertex bytes. So this is how we send the actual vertices to the GPU to operate on. So I have this triangle is just an array of 3 vertices. So, and then we have to tell it the length of the actual of the object you're sending. So it's gonna be we're gonna use the memory layout class and tell it to grab the memory layout of a vertex and then take the stride of that and multiply it by the actual size of the array. So it'll be memory layout vertex stride. Stride is how the length of one vertex object, and then we just multiply it by the count, which is 3. So, and then the index will be 0 because it's the first thing we're sending to the shader. Yeah, and this will send it'll just send this will send the stuff to the vertex function that we declared but haven't created yet. And from there, we just have to tell the render encoder to draw some type of primitive. So you can tell it to draw anything from points to lines to triangles. So we're gonna say triangles and tell it where it starts and where it ends. So it's just gonna starts at 0, ends at the count of triangles. And then from here, we can just tell the render encoder to end the encoding, and then we're gonna grab the current drawable. So current drawable is what the view is drawing at the moment. So if that is not nil, we're gonna add it to the command buffer and we're gonna present it. And then from there, we have to tell the command buffer to commit. And that tells it, we're good, draw, please. Okay, so this isn't gonna work because we don't have the shader. So we're gonna go ahead, add a new file from template. It's gonna be a metal file. Let's call it shaders. Oh my God, I misspelled it. Okay, so from here, we can just create the object. So we have to match the objects that we pass in Swift into the metal shading language. The metal shading language is basically like C++, but like with a lot of stuff missing and a few things added that are specific to GPUs. You can also do like a shared struct in like a header file, but I don't feel like doing that. So we're gonna say. So we're gonna say position. Okay, and then we need to tell it also what is going to be returned. So we're just going to say struct fragment and fragment shader. All it needs to know is the color, really. So we're just going to say flow forward color. So from there, we just need to actually implement the vertex function and the fragment function. So there's some keywords that make this easy. So we have to say vertex, and then we have to say what it returns, fragment and then we have to make sure we match the name with what we passed in the renderer. So we have to make sure we call it vertex shader. So it will take in a uint, which is the vertex ID, so it knows which vertex it's actually operating on, and then we have a special thing that tells the shader, hey, this is the vertex ID. Secondly, we have to say pass in the actual vertices. So that will be it's called vertices, and it'll be of type vertex. And it's a pointer, so basically an array. So we can I know. Oh, we need one more thing. We need to actually tell it the position. So we're gonna add another float for position, and that will be called. And then we have this the double square bracket thing that tells it this is special. Okay, and then from here we have our fragment in. It's kind of confusing. I'm calling it out because it's leaving this function. It's gonna go into the fragment shader. So from here we have to just set the stuff we need. So its position is just the vertices, and at the vertex ID dot position, and then color is just gonna be again vertices, the vertex ID dot color, and then we're just gonna return that, and then now we create the so okay, so fragment, and that just returns a flow 4. Make sure it matches the name. And then it just takes that type we created. We're gonna just call it in. And we're gonna just tell it this stage, we just call tell it that it's stage in. Stage in just says what is being passed into the stage of the render pipeline, and then from there we don't really have to do a whole lot. We just say color, just return the color. And from there, let's run it, see what happens. I don't think it's gonna work on the first try because I haven't done this in a while. I feel like just with graphics programming, the error reporting is always so bad, and it just like doesn't tell you what the F is going on. Oh wait, never mind, it worked. What the? Why did it give me that error? Okay, let's run it again. See what happens. Okay, I don't really know why when oops, I did not mean to I don't know why it's working in the preview, but not when I actually run it. That's a weird thing. But as you can see, the preview is working. We are getting our triangle here. And it's got the colors and stuff. So it's a weird ass error. I don't know. I have to go to the gym, so maybe I'll come back and try to fix that. I don't know. Wouldn't be one of my videos if some weird bullshit didn't happen. Anyway, as usual with Xcode, the issue was not an issue at all. I just had to clean my build folder. And then when I ran it, it worked. So yeah, I didn't do anything. Yes. Here's the triangle. Cool, sick, look at that. Now you know how to make a triangle. Okay, I'm back from the gym and feeling a little bit better. I'm glad I actually got in there and got in some movement because I really haven't moved much at all today. But, sometimes life's about just forcing yourself to do what you should be doing instead of what you want to do. But also, you should do what you want to do as well. I don't know what I'm talking about. I don't have anything like wise or anything to say. But what I do have to say is I am going to eat chicken thighs because I'm tired and I'm hungry. And my sheets are in the dryer instead of on my bed because I was cleaning and I forgot to press the wash. I forgot to start the dishwasher, the washing machine. So it's taken much longer than it needed to. So that's cool. All right, I don't know why I'm on here complaining. Life is good. Let's just, I'm gonna eat some chicken.